Hello and welcome to this technical explainer video where I will attempt to explain the stereo system in FirComp 2. I'll start off explaining how to use the stereo system, and then I'll do a bit of explaining on how it works behind the scenes. Internally, FirComp 2 is a dual mono compressor. This means that it's two compressors, but the controls affect both compressors, and in the default state, both compressors get the same sidechain signal, which is a mixture of left and right. We have four controls that relate to the stereo system in FirComp 2, but we're only going to talk about three of them in this video. The one we're not going to talk about is the mid-side control, and that's purely because we're going to use left and right as examples. In mid-side mode, our left and right channels become mid and side channels, and everything gets encoded and decoded automatically behind the scenes. I'll purely be talking in terms of left and right in this video to keep things simple. So, let's look at the link control first. When FirComp 2 is 100% linked, both the left and right channels get an equal mix of left and right signals. But let's first explain that some compressors link the amount of gain reduction at the end of the sidechain. FirComp 2 doesn't work like this, and there's a few technical reasons why relating to how it does detection, but also I prefer the way that it sounds doing it this way. Linking of the stereo signals happens on the way in before detection and not on the way out during gain reduction. Hi, it's John from the future here. I've just made this diagram of the topology of FirComp 2, showing where the sidechain link and sidechain balance module sits in the topology of FirComp 2. As you can see, it's in the sidechain working on an absolute value, i.e. after full wave rectification. The rest of the sidechain, i.e. all the normal compression stuff, comes after this, and then we multiply by the audio signal. The highlighted blue module is what I'm talking about in this video, the sidechain link and sidechain balance module and how it works. So the first control that we're going to look at out of the three controls is the stereo linking control. And it should be fairly obvious to anyone who's done stereo compression what this does, but I'll explain it anyway. At 100%, we are completely linked, and that means that both compressors get an equal combination of the left and right signals. 0% linked or unlinked, we effectively have dual mono compressors that know nothing about each other. And at 50%, the left signal will get a small amount of the right signal mixed in, and the right signal will get a small amount of the left signal mixed in. So we have our linking, and it does exactly what you would imagine. The next control is the sidechain balance control. By default, it's at the center. As we turn it to the left signal going into the left detector stays at the same volume, so is completely unaffected, but the right signal going into the right detector gets reduced in volume. The left-hand side of the control is effectively a volume control for the right-hand side of a detector. And as we turn the sidechain balance to the right, the volume of signal going into the right-hand detector stays the same, but the volume of signal going into the left-hand detector is decreased. Another way of thinking about this is that this is a relative threshold control, in that when we turn the control to the left, the right-hand side threshold gets lifted up, but the left-hand side threshold stays the same. Or when we turn to the right, the left-hand side threshold gets lifted up, and the right-hand side threshold stays the same. So it's not quite the same as a pan control that you might find on a mixing desk, but it is kind of similar in concept. The simplest way of explaining it is, do we want to compress the left more, or do we want to compress the right more? Now, what makes this complicated is the fact that when we adjust this sidechain balance control, you will see that although the linking control doesn't move, the amount of the rotary control that is filled in the lighter grey color changes. So the easiest way to explain this is by example. So let's say I type in -10, and that gives me 10 to the left. That means that the signal going into the left detector is unaffected, but the signal going into the right detector has been reduced slightly in volume. But why has our linking control changed its appearance? The reason for this is that as we change this, the amount of the left channel that gets mixed into the right channel is unaffected. but the amount of the right channel that gets mixed into the left channel detector is also brought down in volume. I've created another diagram to show what goes on inside the sidechain link and sidechain balance module. As you can see, before the signal from the opposite channel is mixed in, the signal to be mixed in also has the balance applied to it. This signal, which has the link and balance applied to it, is mixed in to the normal sidechain signal, and then that signal is then balanced before going to the detector. So the sidechain balancing, or sidechain pan, happens twice. Once when generating a signal to link into the opposite channel, and again when sending to the detector. So at -10, we have a strange thing happening where the left channel detector gets a smaller amount of the right channel detector added in, whereas the right channel detector gets the full amount of the left channel detector mixed in. And then the whole thing is panned. So we are effectively overriding the linking for one channel, but not the other. Whereas as we turn this down, we can see that the sidechain balance has no effect when everything is completely unlinked, because there's no linking to do anyway. Finally, I will talk about the makeup balance control. Let's say that we're doing 6 dB of makeup gain. When it's in the center, both the left and the right channels have 6 dB of makeup gain applied to them. As we pan this to the left, the amount of makeup gain occurring in the left channel stays the same, but the amount of makeup gain occurring in the right channel starts to reduce. And all the way to the left, there is no makeup gain being applied to the right channel, and the left channel has 6 dB of makeup gain applied to it. So this is not an output pan. This is only a pan of the added gain. And the reason it's done this way is so that as we estimate the perceived amount of gain reduction, FirComp 2 can also estimate the correct makeup gain balance in order to maintain the same stereo balance as the input signal. So you will see an indicator on here, and that indicator has nothing to do with these parameters because that indicator only relates to the loudness monitoring. So if you compress a signal that's already panned to the left on the way in, the makeup gain balance will try and apply that pan on the way out. So you have these snap makeup and snap balance controls. If you click both of them, the compressor will try and match both of the volume and the balance to what it's receiving on the way in, or its best possible guess. All you really need to do is decide, do I want to compress the left or do I want to compress the right hand side more? Do I want the compression to be linked or do I want it to be fully unlinked or somewhere in between? And I want a certain amount of makeup gain. Do I want less makeup gain on the right or less makeup gain on the left? Sidechain balance goes from center to hard left, and it actually goes to -50. So it goes to plus and -50. And it's based on the idea of -30 dB and then snapping to -infinity. If we set linking to 50%, what that means is that -15 dB of the left channel is mixed into the right channel, and -15 dB of the right channel is mixed into the left channel. And it goes all the way down to -30 dB. And then here we have -infinity dB. Let's set linking to 75%, and let's set the stereo balance to -10 left. So that means that we have -10 out of 50 times, so that gives us -6. So this means that the right hand channel is being reduced in volume by 6 dB, and the left hand channel is unaffected. And this means that the amount of right hand side channel being mixed into the left is reduced by -7.5 dB, and the amount of left hand side channel being mixed into the right is also reduced by -7.5 dB. So time to get out the whiteboard and draw a signal flow diagram explaining this a bit better. The sidechain balance is set to 10 left, which is equal to -6 dB, and the sidechain linking is set to 75%, which is equal to -7.5 dB. The formula for converting from decibels into kind of a linear level is 10 to the power of x over 20. So our sidechain balance as a multiplier, we convert -6 dB 10 to the power of minus 6 over 20. We're going to call that 0.5. We're just going to use approximate values here. And then our sidechain linking of 75% gives us minus 7.5 dB. And by the way, the fact that this is 7 and a 5, that's a complete coincidence. So that gives us 0.42. So with these two figures, let's look at our input signal processing of the sidechain. And remember, this is on a rectified signal. And we're going to have something like this, where this is our left signal and this is our right signal. So that's time, and this is a linear level. We do the panning after the linking, but we also do the panning before the linking. So what do we do to do our minus 10 left? Well, scroll back up. Sidechain balance is 0.5. So we have our left times 1, and we have our right times 0.5. So this goes here, and then this also splits and gets swapped over. So this is a temporarily panned signal. And then we need to do our linking, which is multiplying by 0.42. So that becomes times 0.42, and that becomes times 0.42. Let's extend these lines. So we end up with left plus right times 0.5, which is the balance, times 0.42, which is the link. And then we have to scale this so that it becomes normalized to 1 as 1 plus 0.5 times 0.42. And then on the right-hand side, we have right plus left times 1 times 0.42, which is our linking, divided by 1 plus 0.42. And this gives us a signal which has not yet been panned, but has had a panned and linked signal mixed into it. And then finally, we do the actual panning of this, which is a simple, the left gets multiplied by 1, so no change, and the right gets multiplied by 0.42. So this is our panning, this is our linking. Right gets panned and linked into left, left gets panned and linked into right. We add it all up, so the left signal gets a little bit of the right signal mixed in, which has been panned, the 0.5, and linked, the 0.42, and then scaled, so everything stays the same level. And the right-hand signal gets a bit of the left-hand signal mixed in, which is just the linking percent, and then that gets scaled there. And this gives us a signal which has had the opposite side panned and linked into it, but then itself needs to be panned, because as you see, the actual left and right has not been panned yet. It's just had the other side panned into it. And then that is what goes into our level detection. And the rest of the compressor sidechain continues from here. And that's how it works. So that when you adjust your sidechain balance and you still have some linking, the mix of linking and pan gets intelligently adjusted. I hope that makes sense and is somewhat interesting. Thanks for watching if you got this far, and let me know any questions.